The next video, we've already talked about the unit circle and how the unit circle forces it to be a radius of 1. So we're going to apply this idea of a unit circle to help us solve some of these trig value functions. So since we kind of already talked about in the previous video, what we're going to do is going to go and find the exact value of each expression. If it's undefined, write undefined. So the first one they asked us to do is the cosine of pi force. Now pi force is an equivalency of 45 degrees. So what we want to do is we want to mark on our circle here. We might enlarge that just a bit. So first thing I want to do is I want to map out from standard position pi force angle. So pi force radians said is equivalent to our 45 degrees. So this is pi force, which is our 45. Always draw your reference triangle back down to the x-axis. So in a 45, 45, 90, here's kind of what we talked about yesterday. We said in the 45, 45, 90, we have ratios of 1 to 1 to square root of 2. But that doesn't make it a unit circle, and they're specifically asked us to think about the unit circle. They're getting us primed to use unit circles to speed up the process a bit. So if our radius is the square root of 2, we're going to create a radius of 1 by dividing by the square root of 2. And now we have a radius of 1. If I divide one side by the square root of 2, I have to divide all sides by the square root of 2 to keep the triangle in the same proportion. So the opposite side is going to be, in simple triangle form, square root of 2 over 2. The adjacent side is going to be square root of 2 over 2. And the coordinates of our ordered pair, and that's the value and the beauty of our unit circle, is we can find any coordinates on the circle that we go around, and the coordinates of this particular spot when we stop at pi force is square root of 2 over 2, square root of 2 over 2. So now they ask us to find the cosine of pi force. The cosine of pi force is equal to, in the unit circle, what I'm going to do is write down the actual definition. It's x over r. You always want to find the x coordinate over the r. So our x coordinate is square root of 2 over 2, and our radius is 1. So we would put the square root of 2 over 2 divided by 1. Well, when it's a unit circle, dividing by 1 has no impact on your final solution, so it's just square root of 2 over 2. So in reality, if you have a unit circle, the value, since the value of r is 1, it's x over 1, it's really just the x value. So when we have a unit circle, all we need to do is find the x coordinate of the ordered pair that finds the location of the point that rotated around this circle at pi force radians. So first example is concluded. Let's try another one. Sine of 120 degrees. So we're going to find the exact value of the sine of 120. First thing I want to do is I want to rotate an angle of 120 degrees. So from the positive x-axis, rotate 120 degrees. So to find the cosine of 120 degrees, what we do is we use our reference angle to help determine that. So if that is 120, I'm going to back that off just a little bit. Then our reference angle that we're going to use, here's the terminal side of our angle. We have an ordered pair that's going to be connected back to this circle. What is the coordinates of this ordered pair if we rotate 120 degrees around a circle? So in order to find that, we're going to use the reference angle. The reference angle is always drawn back to the x-axis. That is 180 degrees if we went to the negative x-axis, so that is a 60-degree reference angle. It's 180 minus 120. Draw your reference triangle back down to your x-axis, and what we're working with is a 30, 60, 90. So always across, here's what we have memorized. Always across from the 60-degree angle is a square root of 3. So across from the 30-degree angle should be a length of 1. The hypotenuse should be a length of 2. Again, they're specifically asking us to work with a unit circle. So to create a unit circle, I have to divide the radius by 2 to get a radius of 1. So if I divide the radius by 2, then these other two sides have to be divided by 2. Now, one of the things we've got to be really careful with is anytime we go to the left, that's a negative. This time we're going up, that's a positive. So once you get out of that first quadrant and you start getting to the second quadrant, third and fourth quadrant, pay attention to the signs of your ratio. So the ordered pair, the location of this point is a half a unit to the left, which means it's negative, and then up square root of 3 over 2 units. So that's positive. And this one, they want the sine of 120. So the sine of a 120 degree angle is equal to y over r. But because r is 1, it's nothing more than the y coordinate of that ordered pair, which is simply the square root of 3 over 2. Next example. We want the cotangent of 210 degrees. So the first thing I'm going to do, starting on the positive x-axis in standard position, rotate 210 degrees. So 210 degrees would put me approximately here. I want to make sure I get the terminal side located. That's going to put me at a point on the coordinate plane. So if this is 210 degrees, I always want to get the reference angle back to the horizontal axis or the x-axis. So that means we went 30 degrees past 180. So anytime you get in the third quadrant, it's your angle minus 180. So we got a 30-degree reference angle. We're going to use this reference angle and this reference triangle to help figure out the exact coordinates of this point. So to do that, we'll come back to our ratios that we have. Across from the 30 is 1. Across from the 60 then is the square root of 3. And then across from the hypotenuse is 2. So that would mean we have a radius of 2. So just like we did in the previous problem, we'll divide by 2, get a radius of 1, divide by 2, divide by 2. Okay, and now that we're in the third quadrant, we've gone to the left. That means our x-coordinate is a negative, and we've come down. That means our y-coordinate is negative. So the coordinates of that ordered pair have to be negative square root of 3 over 2, comma, and then a negative 1/2. So since they want the cotangent of 210-degree angle, what we need to do is make sure that we write it's the x value over the y value. So the x value is a negative square root of 3 over 2, and the y value is a negative 1/2. And now we have a complex fraction. To simplify a complex fraction, I'm going to have to kind of, well, I'll just clear out some space here. We're going to flip that bottom number, so it's dividing by, so if you can think of it as negative square root of 3 over 2 divided by negative 1/2, and then that's a negative square root of 3 over 2, then times the reciprocal, which will be a negative 2 over 1, which means the 2's will reduce, and negative times negative is positive, so we'll have a positive square root of 3 over 1, or simply square root of 3. So the cotangent of 210 degrees is equal to the square root of 3. Now, whenever I'm dealing with tangents and cotangents, it's easier if you don't use the unit circle. As you can see, if we use the unit circle, we're going to be creating fractions here for our opposite and adjacent sides. If you go back to the triangle, let me just draw the 30-60 right triangle over here. Anytime it's tangent or cotangent, and you have a reference angle of 30, 60, or 45, I'm going to just use the 1, the 2, the square root of 3, because now the cotangent is a lot easier. If I want the cotangent, it's the x-coordinate over the y-coordinate, and it's the square root of 3 over 1, which is just square root of 3. So something to keep in mind when you're working with tangents and cotangents, the unit circle probably makes it a little bit more messy because you're going to come up with these complex fractions if you use the unit circle. Where if you used your original numbers that we memorized for a 30, 60, 90, and 45, 45, 90, then you won't have to work those complex fractions. So, next one is the secant of 7 pi fourths. Okay, so we got to figure out where 7 pi fourths is. When you're dealing with radians, a lot of times what you want to do is this is 7 pi fourths. You could say this is 7 of those 45-degree angles. So you could do it that way. And if you have 7 45s, that is 315 degrees. Another way to think about it is 7 pi fourths is darn close to 8 pi fourths, and 8 pi fourths represents 2 pi. But it's going to be one of those pi fourths short, so it's really 2 pi minus 1 pi fourths. So think about going a negative pi fourths. That's another option that you have. Or you can rotate 315 degrees. Either way, these are coterminal angles that we studied earlier. So I'm going to draw a 45-degree reference triangle and a 45-degree reference angle back to the positive x-axis. Drawing the triangle in there, 90 degrees. Now we have the ratios of 1 to 1 to square root of 2 memorized. Getting them in the unit circle, we'd have to divide by the square root of 2, which is going to make a radius of 1. Now we have the unit circle. We also have to divide the other two sides by the square root of 2. So if we rationalize, it's the square root of 2 over 2. And the square root of 2 over 2. Okay, now in this example, what they want us to do is they want us to find the secant of 7 pi fourths. The secant is the x value over the r. And the r value in this problem isn't simply a 1. So all we need to have on this problem is we put the adjacent side, which is the square root of 2, all over 2. And that's a positive because we went to the right. Officially, on this ordered pair, we'd have the coordinate square root of 2 over 2, comma, and negative square root of 2 over 2. In just a second, I have a little interruption I got to take care of. Okay, sorry, I got that taken care of. And as I was doing that, I noticed I wrote this down incorrectly, so let me come back and correct that part. The secant correctly is r over x. So in this problem, what we're looking at is a radius of 1, since our radius of the unit circle is 1, so it's 1 divided by the x-coordinate of our ordered pair, which is the square root of 2 over 2. And now what we're up against is simplifying this complex fraction. So simplify, what we're going to do is we're going to have 1 divided by the square root of 2 over 2, which means it's 1 times 2 over the square root of 2, which means you got 1, well, just 1 times square root of 2 over 2, and now we're going to simplify by rationalizing the denominator. So we're going to multiply top bottom by the square root of 2. On the bottom, we're going to have square root of 2 over square root of 2 times square root of 2 is 2. And we got 2 times square root of 2, or we get just simply square root of 2. So the secant of 7 pi fourths is equal to square root of 2. Okay, 4 examples of how to use the unit circle to find exact trig values.